Hello, students. Welcome to our next session. And for today, we shall be talking all about the law of sines. Okay, the law of sines can be used with oblique triangle. When we say oblique triangle, it is a triangle that contains no right angle, which means that the angles here may be obtuse or acute, but no right angle inside it. So if that's the case, we can apply the law of sine. Okay. So the law of sine is here. This is the law. So the ratio of sine of the angle A to its opposite side A, so A over sine A, is just equal to B over sine B, and it's also equal to C over sine C. Or we can interchange the position. We can say sine A over A equals sine B over B equals sine C over C. This is the law of sines. Okay. Now, when to use the law of sines? First, if the given are two angles and one adjacent side. So angle, angle, side. So the given angle and angle here and its adjacent side. So we can apply the law of sines. Also, we use the law of sine if it is in ASA case, which means that two angles and their included side are given. These are the two angles, alpha and beta, and we have the included side. Okay? And also, we can also use the law of sine if we have the side-side angle, meaning to say, given two sides and one angle. Just like this. Okay, let's have an example. Given that angle A is 102.4 degrees, angle C is equal to 16.7 degrees, and side A measures 21.6. Now, can we use the law of sine here? Let's check it out. Given the angle here, an angle here, and the adjacent side, the two angles and the adjacent side, so that is an AAS case, or angle-angle side case, meaning to say we can apply the law of sines. So now, how do you find angle B? That's very easy. We know for the fact that in any triangle, the sum of the interior angles is equal to 180 degrees, which means that angle B here is just equal to 180 degrees minus the sum of the two given angles here. So we can get 60.9 degrees. So therefore, the measure of angle B is equal to 60.9 degrees. Understood? Okay. How about the angle, the side B? How do we get the side B here? So we apply the law of sines. It states that the ratio of A over sine A is equal to B over sine B. It follows that we have this formula. A over sine A equals B over sine B. And A measures 21.6 and angle A measures 102.4 degrees, and B is the missing, and angle B measures 60.9 degrees. So we can now get the value of B. So to get the value of B, class, just multiply 21.6 and sine of 60.9 degrees and divide the answer by sine of 102.4 degrees. So B equals 21.6 times sine of 60.9 degrees all over sine of 102.4 degrees. So simplifying that further, we get 19.3. That is the measurement of side B in the given problem. How about side C? How do we get, or how do we find the measurement of side C? So the same procedure, we use the law of sines, and the formula is A because these are the given. So we always use this as our reference ratio, the given. So A over sine A equals C over sine C. So A, that is 21.6. Angle A is 102.4 degrees. And C is the missing part. And angle C measures 16.7 degrees. So again, the same procedure. To get the value of C here, we just multiply 21.6 and sine of 16.7 degrees and divide it by sine of 102.4 degrees. So there you have it. Multiply this and divide by this. So C here is equal to 6.4. Okay. Did you understand? If yes, let's move on to the next example. Given that the measure of angle X is 17.9 degrees and the measure of angle Y measures 78.4 degrees and side Z measures 36.8. Is that ASA case? Let's see. We have the given angle, that is angle X, and also angle Y, and included in the two angles is this Z. So it is an ASA case. So therefore, we can apply the law of sines. So in that way, let us now try to find the missing parts here. First, it's easy to get the angle Z. So how do you find angle Z? The same procedure, just add the two angles here and subtract it from 180 degrees. So we get 83.7 degrees. Okay, let's move on. How about side X? How do we find side X? So I repeat, we always use the angle opposite side given as our reference ratio. So to get the value of X here, we apply the formula Z over sine Z equals X over sine X. So we have Z measures 36.8 and angle Z measures 83.7 degrees, x the missing part, and angle x measures 17.9 degrees. So I repeat the procedure. To get the value of x here, of side x, we just multiply these two and divide by sine of 83.7 degrees. So we get 36.8 times sine of 17.9 degrees over sine of 83.7 degrees. So by clicking into your calculator, we get 11.4. So the value of x is 11.4. Okay, last. How do we get the value of y? It's very simple. So again, we use this as our reference ratio. Z over sine z over y over sine y. There you have it. And it follows that we have the value of z is 36.8 and angle z is 83.7 degrees. The value of y is missing, so that's what we are going to get or to find. And the value of angle y measures 78.4 degrees. So again, to get the value of y, we multiply 36.8 by sine of 78.4 degrees and divide it by sine of 83.7 degrees. There. So if you're going to calculate that using your calculators, we can have y equals 36.3. So therefore, y here measures 36.3. Okay, class, the SSA case will be discussed in my next video. So just check it out. Thank you for listening and watching the video.